Welcome to the Real Python Podcast. This is episode 232. What are current approaches for analyzing the emotions within a piece of text? What tools and Python packages should you use for sentiment analysis? This week on the show, Jodie Burchell, developer advocate for data science at JetBrains, returns to discuss sentiment analysis in Python. Jodie has a PhD in clinical psychology. We discuss how her interest in studying emotions has continued across her career. Jodie covers 3 ways to approach sentiment analysis. We start by discussing traditional lexicon-based and machine learning approaches. Then we dive into how specific types of LLMs can be used for the task. We also share multiple resources so you can continue to explore sentiment analysis yourself. This episode is sponsored by Sentry. At Sentry, we don't just build tools, we use them to debug our trickiest slowdowns. Hear the whole story later in the episode and find others like it at blog.sentry.io. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, Jodie, welcome back.
Hi, it's been a while. It's been almost a year, actually.
Yeah, I know. I've missed you.
Oh, same.
So I'm excited to have you back on. And we're kind of diving back into an area with the natural language processing. You were on episode 119. The title of it was Natural Language Processing and How ML Models Understand Text. Today, we're going to take that kind of a little bit further. And so if there's some deeper research you need to know about the idea of, how does NLP work, you can kind of go there. It's been a busy year.
Yes.
You've been at a lot of conferences. I don't know if you want to mention any conference talks or things that you've done recently, or we can always list them at the end and share some, but any shout outs?
Yeah. So again, this year I've been mostly focusing on LLMs. I decided to kind of go a bit more into maybe like specific pockets of things that interest me. So kind of shout out, my PyCon US talk this year was on hallucinations. So if you want to know more about those, that recording's already up. I keynoted at PyCon Italia, my first keynote. I was so stoked to get asked.
Awesome.
And I decided to go back to my psychology background, which I believe we'll be talking about a bit today. And I was talking about things like, are LLMs sentient? Are they intelligent? So just debunking a few of those myths.
Yeah.
And then recently I did another keynote, which is unfortunately not out yet, but that one is about how we actually measure LLM performance and investigating how fragile that is. So you can see I've sort of gone back to my academic roots a bit and kind of going away from, more of the applications and talking more about the more kind of academic side of things. So it's been quite fun. Hard talks to write, but yeah, a lot of interesting stuff.
Did you celebrate your keynote in Italy with a nice pasta dinner there?
I did. And I will also say I celebrated the keynote, the second one in Porto, with maybe a few too many Porto and tonics and karaoke. I sang Britney Spears.
Oh, wow. What's your go-to song?
Toxic.
Oh, yes. There you go. I love that song. That's great.
Yeah.
All right. Well, cool. So we wanted to dig into a topic that is still really useful in the ML world of sentiment analysis and how we can kind of use that to derive information from written text and so forth. And I guess with lots of the translation tools and stuff like that, we can go beyond written text and use it in other ways. So yeah, I guess we could start maybe with a little bit of your background. You said you wanted to talk about, well, you have a PhD, so.
So yeah, It's kind of funny. So sentiment analysis was, let's say, my gateway into NLP because,
Okay.
so quick background on what I studied. So I studied psychology, as we've already mentioned. That's what I did my PhD in. And I was always super fascinated by kind of personality psychology, clinical psychology, and emotions, relationships. So I actually did my PhD in hurt feelings.
That's great. I don't know if you know the song.
Oh, yes. Yeah, no, that was the theme song from my
Yeah, there you go. Okay.
Flight of the Conchords. Yeah.
Flight of the Conchords. Yeah.
Yeah.
Got hurt feelings.
Yeah. I did a radio interview during my PhD and they played that as part of the interlude.
Oh, nice. There you go.
But yeah, I also did like another project on romantic jealousy. So I really still like the emotion stuff. And when I kind of discovered that there were ways that you could automatically detect emotions with, programming, I just thought that was super cool. So
yeah,
I started off with sort of simpler stuff and we'll talk about those sort of approaches. But as I've gone through learning more about LLMs, obviously they have applications for this as well. I promise this will not be an AI episode.
Okay.
There will be a lot of other stuff as well, but obviously
stuff you can play with as we go.
Yeah. And the LLM stuff is pretty accessible as well if you want to play with this. There you can get models out of the box that just work. So
nice.
Yeah.
Okay. You wrote this thing about sort of measuring Ekman's basic emotion types, and I had to look it up. Sorry.
That's okay.
I love that they use the what's the Pixar movie?
Oh, Inside Out.
Inside Out. Yeah, they have a lot of. Let's give you an animated way of explaining this, which is kind of funny. But this idea of not only what these sort of, I guess, core emotions are, but one of the things I thought was interesting is, well, first off, like you mentioned it a little bit, what led you to studying emotions?
Yeah, I think it's because the thing that always fascinated me the most in psychology is like how people relate to each other in really close interpersonal settings. So romantic relationships is obviously kind of the core one.
Sure.
But any sort of relationship where you have what's called an attachment bond. So it's basically like you have this sort of sense of being able to rely on that other person as a sense of your kind of psychological stability. And I was always kind of fascinated, like what happens when things go wrong with those relationships? And you have emotional fallout. So you have jealousy and you have hurt.
Right.
But I also just really like when I was a clinical psychologist, there's this kind of like very complex relationships between your body and your emotions and your thoughts. And there's different kind of schools of thought about how they relate to each other.
Yeah.
But say in particular, we were actually talking about mindfulness before we started recording.
Yeah, we were.
Part of kind of the idea of mindfulness is being able to sort of recognize the physiological changes that come with an emotion. And emotions do have like kind of a signature on your body.
Yeah.
And recognize that before you react to it and then, have the thought cascade and the behavior cascade. So I always just found it really interesting because it's such a primitive part of who we are, but they give us such useful information and they're still very like an important part of our psychology. So yeah, that's cool. I just find them fascinating. Yeah. Still so many years later.
Yeah. I know that we could go down a massive rabbit hole here. Yeah. One of the things I feel like might come up in this is this idea of, they have this idea of a dimensional emotion classification. And I'm like, well, what does that mean? Like, is that like how deep the emotion is or how strong the emotion is? Or like, what does that classification refer to?
Yeah. So it's more that instead of saying like, you feel stronger or weaker fear or whatever, you sort of break down aspects of emotion into different dimensions. So the most common one is that you have polarity. So polarity is sort of whether an emotion is positive or negative.
Right.
You have arousal. So it's sort of like how physiologically kind of worked up you get. And then you have dominance, which is the expression. So it's sort of the idea that it's a combination of all three. So you can have like a strongly negative emotion, but you suppress it. And then that would be sort of a negative polarity, high arousal, and high dominance. So yeah, it's just
you get this sort of directionality. It's very vector, if you will.
Yeah. It's a three-dimensional vector space. It always comes back to vector spaces. Yes.
So that's cool. I guess that kind of is good. Then that kind of gives a way to kind of relate that information. So
yeah, and I should just also say, like the dominance model, you can imagine how difficult it is to extract that from text. So this is really not used as part of sentiment analysis, but one aspect of it.
But you can feel those vibes in a one-on-one meeting with someone.
Oh yeah, yeah.
Interesting. I guess where do we start? Like, where do you want to dig in here? You kind of have a few things listed. We have a document we're kind of sharing here, which I think is great. And I feel like some of it is techniques that have been around for a while and then kind of moving into where more modern techniques have kind of developed.
Yeah. So let's maybe first talk about, it's probably something we've talked about on other NLP episodes or, other people have talked about it when working with text. But something to be aware of is obviously a body of text is a complex document sometimes. So it could be as short as a tweet.
Sure.
Or it could be as long as a novel, right? And so if you think about what kind of complexity of sentiment or topic or anything you expect to be expressed, it's obviously going to be more variable the longer the document is and the more complex it is.
Right.
So it's also really important to sort of think about, okay, at what level is it reasonable to try and analyze the sentiment of this piece of text? Like, should I be doing it sentence by sentence? Is it reasonable to analyze the full text? Like maybe a review. Maybe you want to analyze the full review just to work out if it's positive or negative. But there's also things like maybe you want to know how people feel about specific aspects. This is called aspect-based sentiment analysis, unsurprisingly.
Yeah.
So it could be, let's go back to the review example. Let's say someone feels very positively about, I don't know, so let's say it's a coffee machine. They feel very positively about the design, but they feel negatively about the amount of noise it makes. So you can see you're getting kind of more information here rather than they just didn't like it or they did like it. And then, you can also kind of combine it with other techniques. So you might do something called topic modeling, where you just classify what that sentence or what that document's about. So then okay, they're talking about the design of the coffee machine and they're talking about, I don't know, the type of coffee beans it takes. I'm not really good at improvising.
That's okay. Yeah.
And so you could sort of say, okay, they're focused on functionality. That would be the topic. So
how many features does this machine have?
Yeah.
I'm a big coffee person, so I have this fancy Breville.
Oh.
I've had it for 5 years now, so it's actually paid for itself easily.
Yeah.
And I make espresso in it. It has its own grinder. So I get what you're talking about there. And all the things, if I wanted to do like lattes and all that sort of stuff, like those kinds of features. So you'd be looking at sort of, I guess, associations then, as far as like where the words are kind of connected to, like you said, like the overall performance, but but noise might be another kind of category thing. And then also like other features you're looking for. And then I guess price would be another one that you could kind of say, okay, these words around price or whatever is allowing you to kind of divide up the sentiment.
Yeah. And we'll kind of go through different ways of doing sentiment analysis. So this will sort of overlap with what we're talking about. But there are more and less sophisticated ways of extracting this information. So it's working with text is complicated.
Well, I sort of thought when you mentioned like you could look at an entire novel and like, oh my gosh, that would be really intense. And you'd really have to be searching in there.
Yes, I probably wouldn't recommend doing that. I'd probably say if you want to do that, put it in a vector database, but we can come back to that.
Yeah, we're much more likely looking at, in our case of experimenting, is like reviews or stuff like that. Yeah, okay.
The first kind of technique I want to talk about was the first one I actually came across when I was looking at sentiment analysis. And these are techniques that are called lexicon-based. So they're based on a dictionary or a lexicon. And initially when you come across it, it seems like I always feel like the documentation on these packages is maybe not that clear, because I feel like it's almost written for an audience that already understands how they work. And so when I first came across them, I thought, oh, wow, like they look so sophisticated and complicated. But all they are under the hood, I shouldn't say all they are. It's, there's a lot of work that goes into it. But it's literally someone gets a dictionary of words, a lexicon, and then they give it to someone who will manually annotate each word with the sentiment associated with it. So when we talk about sentiment with these lexicon-based approaches, we're really just talking about polarity, which I mentioned earlier, also called valence, which is how positive and how negative it is. We're not talking about like specific emotions. And yeah, basically it's like, okay, the word sad has a sentiment of -5 or whatever. The word happy has a sentiment of +5, whatever the scale is.
Yeah.
And then generally you will have someone who has some sort of understanding of linguistics involved in creating a rule set, which will identify each of the words in the sentence, match them to a lexicon, and then combine them in some sort of generally sophisticated way. So, to take into account a negation. If you say, I'm not happy, it will be like, okay, so we don't say happy is +5 here. We say maybe it's -3.
Okay.
So this is the general idea. And these are a super common way of doing sentiment analysis. They're sort of the oldest way of doing it. And they're still very successful. It's a lot of Python packages. Not a lot, but like a few commonly used ones, and still work pretty well.
Yeah. I wonder about the process of keeping them up to date with the way language sort of changes or words being added to it. I have a tangent. There's a book called Power versus Force. Have you ever heard of that book?
No.
It's I don't know if it's a religious book or like a psychological book or whatever, but it's basically, it has to do with the power that words have, and it has a rating scale similarly to what you're talking about, and like how like negative sort of stuff, and like one of the dividing lines is pride. Pride is like this dividing line. It's still sort of negative, but entire militaries run on pride. And other things like that. But it's, and then like, you get to like love and other kinds of things. It's an interesting book. I don't know how valid things are in it entirely, but it's interesting because it's one of the few times I've looked at something that did what you're talking about, of like enumerating, or like coming up with a scale for words and how they are in your life and how you use them and relate to things. So
I always think about the process of the annotators as well. So one of the packages, one of the most well-known ones, is called VADER.
Okay.
And I did look up the acronym because I know you love knowing what the acronyms stand for.
Yes, please. Yeah.
So this one stands for Valence Aware Dictionary and Sentiment Reasoner, but sentiment, the E is stressed. So
this is the capital. I saw that. That's so funny. Yeah. So it's a very much a bit of a backronym.
It's a very backronym.
Yeah.
But calling it cool. VADER is certainly convenient. So all applause to the authors for doing that.
Yeah.
But I remember, like, I read the paper that they put out with it, and they actually used Mechanical Turk to get all the ratings. So they had like multiple people doing the ratings and, try to get more reliability that way.
Yeah.
I don't know if they're actually actively updating that dictionary though, but they did take a lot of care to try and include things like abbreviations, like SMH for shaking my head. And they also include emojis and stuff like that. So
yeah. I still have a hard time with some of them.
Oh my gosh.
I'm too old to be like that up to date on texting sometimes. I'm like, what?
I remember reading this thing, which was like, my grandma thinks that LOL means lots of love. And I got a text from her saying, your grandpa's in hospital, LOL, grandma.
Oh no.
Grandma, no.
with a heart sign next to it.
Like, whoa. Yeah. Thought things are a bit better between them, but anyway.
Yeah, exactly. What are you going to do? We got to laugh.
Yeah, that's right. So yeah, the other package in Python that does this sort of lexicon stuff in terms of like sort of mainstream packages is TextBlob. So
okay.
does the same thing. You input a sentence or a couple of sentences and it will output sentiment score, the polarity.
Okay.
Interesting thing about TextBlob is it also includes a subjectivity score. So they did the same thing, like they got people to annotate how subjective or objective particular words are, and then they combine them. And so, yeah, it's kind of interesting.
Be a use case kind of thing, where would that be better? I'm trying to think.
Yeah. So, okay, think about if you got a bunch of reviews.
Sure.
And you want to know if the review that you're given is like someone stating facts, like I checked into the hotel and
this actually happened to me.
Yes, there was a stain on the bed and the shower was leaking. That would be very objective.
Okay.
Versus someone who is like, this is the worst hotel I've ever stayed in.
Right.
I hated it. Because they're both useful. You want to kind of, potentially capture both.
The I feel and the kind of like sort of up here kind of stuff as opposed to like down here looking at the thing specifically.
Exactly.
Yeah.
And the objective stuff is more actionable as well, right? Because again, if we go back to the kind of topic modeling.
Yeah, we can fix that, shall we?
You can work out what's going on. So,
right,
yeah. But I find this really interesting because I've never seen this anywhere else.
That's cool.
Yeah, it's a quite cool package.
Yeah, it would make sense that you would want that in your tool belt, maybe as a second pass on something to kind of give it an idea of like, okay, but this is, or at least like, okay, I'm ready for all the subjective reviews. I'm going to look at the objective ones first.
And then,
because I can do something.
Then I'll work out how much people hate or love me. Yes.
Yeah, exactly. Her feelings.
Her feelings. Yeah.
This week's sponsor is Sentry. At Sentry, we hit a 2-second slowdown in our API response times. Here's how we dug deep and fixed it fast. While monitoring Sentry's backend, we noticed our P99 response time, meaning the slowest 1% of requests, had spiked to over 2 seconds. Starting from our trace view, we discovered our rate limit middleware was the culprit. With our profiling tools, we were able to trace the issue to a classic cold start problem. Luckily, the fix was relatively straightforward. We adjusted our configuration to warm up our servers ahead of time, and our P99 latency dropped to 176 milliseconds, a win in our book. At Sentry, we don't just build tools, we use them to debug our trickiest slowdowns. Read the whole story and others like it at blog.sentry.io. Do you have an example of using VADER that like a project you put it in place?
I do actually. So I will be honest, I have never used sentiment analysis for like a production project. It's more just been for little toy projects.
Experimenting and yeah.
But back when I was better about maintaining my blog, I used to try and do a Christmas blog post and a New Year's blog post. And I think I've only ever succeeded at doing this for 3 years. And I've been maintaining this blog for like 8 years. It'll tell you how good I am.
Yeah.
But I did early on when I was like still getting into sentiment analysis, one which was about how people felt about their New Year's resolutions. So basically like, okay, I tried to do some it was very simple kind of topic modeling. Like it was literally just based on keywords that I thought would be associated with different themes. And then tried to see like, okay, do people feel more positive about weight loss resolutions or travel resolutions and blah, blah, blah. So I think I used VADER for that. VADER was like, I was a big fan of VADER.
Okay.
Back in the day.
So what were your results? Do you remember?
I didn't think there was a big difference between the different topics, but also like my topic modeling was quite crap. So that's probably part of it.
Okay.
But
well, I think that in the construction of them and statement of them, they would generally be positive. I want to do this thing, as opposed to like the follow-up that rarely happens to like, how did you accomplish them?
But it was also very interesting because I think it was probably the weight loss ones were quite self-punitive a lot of the time. Like,
oh yeah. Okay.
Like, oh, I feel so disgusting after Christmas. I should really get back into the gym for New Year's.
Okay.
And then you're like, oh,
Oh, yeah. Okay.
it's sad.
Yeah.
I think that one was the one with the worst sentiment, and then I think travel was the one with the best sentiment.
Yeah. Kind of high expectations.
Yeah, but maybe I misquoted myself because it's been like 3 years since I looked at this blog post.
That's okay.
Yeah.
That's cool. That's good to hear. I mean, that it's an interesting way to use that. I would wonder, it makes some sense where TextBlob would be a little bit handier, in sort of different situations there with the sort of the reviewing things and kind of trying to get almost like a bit of a temperature check with it. So
Yeah. And like you can like there's a lot of sort of social media monitoring software, and a lot of them will have sentiment analysis built into them. And I'm sure it's probably based on these sort of packages. Let's say you can get charts which will show you the average sentiment of tweets or whatever talking about your company over the last month. So it is actually, this is probably one of my favorite applications of sentiment analysis because it's just so useful. But then obviously, like, I think it's super cool being able to use it as a company to be like, hey, like we genuinely want to fix things with our product or the way people are seeing our company so we can extract this information.
Yeah, I wonder about the numeric scales that a lot of people use. There's this NPS thing that I've been a part of because I've been in retail for a long time.
Yeah.
Off and on, this idea of a net promoter score.
Yeah.
And I generally feel people, you should just give them a good or a bad. I don't think having 5 stars is worth doing. This is totally an opinion because I feel like people are like, well, what do I do with that? And they pretty much just go one way or the other, even if it's going to be like a minor thing that they found wrong. They're like 1.
Yeah.
Because they want it to have attention, to it, which is interesting. So I feel like maybe this information, you could then take the words with that and kind of balance it out.
Yeah.
So.
And the interesting thing about these lexicon-based approaches is they will generally give you continuous scores. So because they're because you can
see trends.
Yes, exactly. So it's not just we predict that it's positive, we predict that it's negative. It's that it's more or less positive or negative compared to these other techniques we're going to talk about that generally don't. It's either positive or it's negative or very positive, very negative, whatever. So yeah, it's a useful thing about them.
Nice. So that kind of gets through most of the lexicon stuff, which is kind of like the first approaches that people might do for this kind of thing. Probably good to practice these just to kind of understand how they kind of work and how to set them up. Would you suggest people still play around with them?
Oh, yeah, for sure. And like you can easily get, I think like there's tutorials like very easily available. I'm actually about to publish a blog post. It probably in a couple of weeks.
It might be in time, depending on when it comes out. So yeah. All right, we'll make sure we got a tag there at least.
Yes,
or at least a link to your blog so people can check it out.
Yes. Oh, no, this will be PyCharm, so this will be on the official blog. So, but yeah, basically in those blog posts, I've got some snippets of code on how to apply all of the techniques or almost all of them that I talk about.
Cool.
But, if you don't want to wait for the blog post or you don't want to read it, there's also plenty of places you can look up. And you'll see like these are literally like you import a method, you apply that method to the text and it just spits out the results. They're super easy to use.
Can I ask you a question about when these packages say that they support multiple languages? Are there varying results with that? Like, I feel like English is... I'm privileged. I live in an English country and most programming is in English. And so it's like very centric. And so I have this myopic view of like, well, what happens when you try to look at reviews in other countries and Real Python is an international site. So we have a lot of people visiting from other countries and occasionally things come in different languages, but it's rare. But I wonder about like, I guess there's a couple questions there. Like, okay, well, do they support how many languages, and then how well is that done? And are there issues with that?
Yeah, this is such a great question. So basically, because the lexicon-based approaches, all of the dictionaries are handcrafted, right?
Okay.
There are 2 ways of doing this. So as I understand it, TextBlob has at least one project another language, which is TextBlob DE, which is TextBlob in German.
Okay.
From what I understand, they have actually created a new dictionary and a new rule set specific to German. Because obviously the relationship between words is quite different. So I can actually give you an example from German because supposedly I speak some German.
You need to.
But say we were talking about the negation example, right? So in English, we would say, I am not happy.
Right.
So, okay. But you could say, ich bin nicht froh in German, like I am not happy. You could literally translate that. But you could also put it in a verb form. So, God, is it Forkai? I don't think I'm just making something up, but you can put it in a noun form, sorry.
Okay.
So in that case, the negation is not nicht, it's kein. So I have no happiness would be the translation.
Yeah, interesting.
So you can sort of see that the verb form and the adjective form and the noun form have quite different grammar rules. And so doing a direct translation may not actually work. So
makes me think of the topic of stemming we talked about way back then.
Exactly. Yeah.
And even in English, like feel goes to felt, which is not easy to think of. Buy, bought, buying, buyer. It's like, okay, well, there's things there, but like bought is like so out of the loop there, versus like a borrow, borrowing, borrowed, kind of thing like that. Where like you can kind of think of the stem. And so I wonder about that in other languages where like the construction might be completely different. Like Romance languages follow some nice rules generally. Like you can get around Spanish to French to Italian, and structurally there's a lot of similarity there. But like you go to German and it's like, boom, you blew it up. And English is like so random.
But even with Spanish, like I am not happy would be no estoy feliz. So it's not even like the no is not next to feliz again. So
it's
at the beginning
removed.
of the so it's
okay.
So what I do know is that there is a project called VADER Multi to support multiple languages.
Okay.
It does use the Google Translate API. And to be honest, the Google Translate API is good. It's based on, large language models. I'm sorry, they're already coming back in.
Right.
So it can probably handle a bit of the vagaries and weirdness here. But then how that works with the rule set, which I assume would be designed for English, and then whether, the translation of the word has the same implications, like sentiment-wise in different languages. Like I just feel like it wouldn't work perfectly. I feel like you need to handcraft this, and it's expensive, and you need linguists, and you need people who know what they're talking about to do this sort of stuff.
Yeah, I mean, it'd be good to have people to check it out, run it through its paces and see.
Yeah, actually.
And, I think about like sarcasm and other things that are going to be like maybe just fly right past.
That sort of stuff really doesn't work. But if we have any listeners who natively speak another language and you try it at VADER Multi and you compare it with English, that would be very cool.
Yeah. That'd be interesting. Yeah. I just wondered about that. So have you practiced these tools with other languages other than English?
Yeah. So I've mostly done, one of my NLP jobs, we worked across multiple languages, right?
Okay.
So again, it wasn't sentiment analysis, but it was more, and this is actually a very good lead in, kind of text preparation, like tools, things to do things like stemming or lemmatization or removing stop words and things like that.
Yeah.
So there are definitely tools that exist across multiple languages for those. And the really good thing is you generally don't need to handcraft them yourself, right? Like you don't need to come up with a list of stop words for German or for Spanish, or
you're going to get 90 some odd % of it through
it'll just
sort of automatic means, or
no. It's that people have taken the time to compose this for you. So you'll have some sort of expert in the language, and they will have, say, as part of NLTK,
that'll be part of the package.
Yeah, created a stop word list that is appropriate for German, say.
Okay.
So
Great.
Yeah. And to be honest, they work quite well. Like a lot of the normalization tools, like especially some of the lemmatization tools, which just to remind anyone who hasn't listened to that episode, it's basically taking all of the different grammatical variations of a word and reducing it down to its base form. And it does it by applying proper grammar rules. And so obviously it's extremely language dependent. And yeah, like a lot of lemmatization tools are super sophisticated and they do this very well for the 3 languages I can sort of understand it for.
Okay.
But yeah, that is a good segue to talk about our next way of doing sentiment analysis, which is using just machine learning models. This is very broad, but the general idea is that you have a bunch of text and you have an emotion label associated with it. Again, it's usually just going to be positive or negative, or it could be very positive, positive, neutral, negative, very negative, or whatever, some combination thereof. I haven't really seen any of these models using emotions like fear, anger, joy, but there's no reason you couldn't do that. If you've got the training set, you can do that.
Okay.
And then you process the text like we talked about. You could just base it on the words, and this is called a bag of words approach. So if you want to learn more about that, I think Real Python has an article about it. And then we also talked about that in an earlier podcast.
Yeah, I have a couple links to a couple tools where we kind of go into specific sentiment analysis stuff. One is called First Steps with Python's NLTK library, and then the other one is about classifying movie reviews. And so I'll include links to both of those so people can go. And then I did have an episode really early on, episode 36, where we talked about sentiment analysis for Fourier transforms and kind of diving a little bit further into, some of my first data science episodes.
So yeah, generally the idea is you use the information in the text in some way. So it could be the words in the text, in which case you do those normalization steps we talked about. Or it could be something a bit more sophisticated, like you convert the document into what's called a document embedding. This is just a way of like you just take basically a large language model and you convert the document into some sort of vector representation, and the model will do all the magic for you.
Okay.
And then you pass that into your model, and then it will predict whether the text is positive or negative, whatever. So the advantage of using this technique is all of those problems we talked about with, there's not language support for your particular model. Maybe the thing doesn't work for your specific domain, whatever. It can generally be solved with this approach because you're handcrafting a model that's specific for your use case. Now, the disadvantage is you have to come up with a training set, which means you're probably going to need to make the training set manually.
Right.
And training machine learning models is not always super easy. So
do you end up doing like a divide kind of thing where you're like, well, I want to analyze this group of stuff, and to be able to train it, you would, maybe do a split situation. Of course, you're losing some of the sentiment that you're looking for in that data there, but is that the best approach?
Yeah, absolutely. So it's just sort of your classic machine learning training pipeline. And so what that involves is you will prepare the whole data set, right? You will just take 50,000 reviews or something, and you will hand label all of them. And then what you'll do is you'll split that into 3. You'll have your set that you use for training, and you'll have a set for just kind of testing intermediate models. And then you'll keep one set aside. So that's your validation set. And then you'll keep one set aside, which is your test set. And that's basically the one that you test your final model on. And you just want to know, okay, the performance on this final set, is that going to reflect real world, how it's going to perform in the real world when I actually want to apply this to real reviews?
Okay.
So it's standard machine learning practice with all of its work and complexity. So in terms of tooling for this, it's more kind of like your classic like Python tooling for natural language processing. So you've got packages like NLTK, the Natural Language Toolkit. You've got scikit-learn, of course, for building the models and also preparing the data. And you've got spaCy, which is much more kind of sophisticated way of approaching this. Like the tooling pipeline is really like well developed and allows you to do a lot of this sort of lemmatization, stemming and stuff in a much more kind of, say, production ready way. It's just sort of packaged up a bit more nicely, more clearly.
I'm intrigued by the subtitle on their website, Industrial Strength Natural Language Processing.
Yeah.
What do you think they mean by that? Like, it's much more ready to take on these larger tasks or what have you?
It's partially about the size of the data. It's more like about when you build any sort of data processing, right, you have a pipeline.
Yeah.
And so they've taken more of a sort of data engineering approach, I think, to how they've sort of built the code. So everything is built on the basis of having end-to-end pipelines where it will sort of take in a raw piece of text and spit out the processed text that you need. And you can like tack on sentiment analyzers like TextBlob. You can put that as part of your pipeline. You can tack on models. You can tack on like embeddings. Like it just sort of tries to take everything that you might need to do to a piece of text and make it part of one coherent pipeline. So it's just more sort of stable. It's more reliable. It is more powerful as well. Like the possibilities of what you can do are very wide.
That's cool. It sounds like, I forget the term, but where you can kind of, in my world of music production, it's like you can plug in all these different things and insert these different areas of stuff that you want. You know, choose your own adventure as far as like, okay, I want to have these things go. I mean, I guess they might have a specific order that you might want to approach it, but it's designed pipeline wise to be something where you can grow and expand or add the tools that you need to it. So,
yeah. I should also mention like the two founders of Spacey. They're friends of mine and live in Berlin. They're actually coming over for dinner tomorrow.
Oh, wow. So. All right. We'll say hi. That's cool.
Yeah.
It sounds like a really interesting package. It's kind of like built upon a lot of these other, background tools that we've talked about up to now. And it definitely looks like it has lots of support for lots of other languages. I mean, literally that's one of the first choices is like, what language do you want to work with?
Yeah, exactly.
Which is nice. Have you been using Spacey for a while?
Yeah. So the job I was talking about where I was having to do multilingual text processing, like we all use Spacey. So
yeah.
I started with scikit-learn actually. Still love scikit-learn, but when you have to do more complex stuff, Spacey's definitely better. And I think the code's a bit more readable when you come back to it.
Nice. Yeah, I think that idea of it being, modular would make it rather readable. You can kind of see where you're doing each of the steps and looking at it. This week, I want to shine a spotlight on another Real Python video course. It's based on a topic related to our conversation this week and may help you get started in the world of natural language processing. It's titled Learn Text Classification with Python and Keras. The course is based on a tutorial by Nikolai Yanikiev, and instructor Douglas Starnes takes you through getting started with scikit-learn and the Keras package, defining a baseline model, how to use pre-trained word embeddings, determining the mood of a piece of text through sentiment analysis, what are convolution neural networks, and learning how to tune hyperparameters. If you're interested in exploring natural language processing and sentiment analysis, I think this is a worthy investment of your time. And like all the video courses on RealPython, the course is broken into easily consumable sections. Plus, you get additional resources and code examples for the techniques shown. All of our course lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using our search tool on realpython.com. So this approach, what would you say like are immediate advantages to it over the older systems?
Yeah. So the advantage, like the main advantage, as I said, is you can tailor the sentiment analysis exactly to the data that you have.
Okay. All right.
And it also sort of means that I don't know, if you do want to create an emotion classifier model, you can do that. You can, it's basically whatever data you can prepare.
Yeah. But it may be more work than some of the other ones, or
it's definitely,
there's a different form of work.
It's more work. No, it's definitely more work, because you've basically got to train a machine learning model and prepare the data.
Okay.
Unless you already have it. The kind of downside as well is that it's probably going to be slower. Maybe not.
Okay.
But the lexicon-based approaches are incredibly fast. Whereas depending on the model you build, it might be a tad slower. So,
Okay, because it's more matching things. I don't know. I'm trying to think of what's making it faster or slower.
Yeah.
Process. I mean, obviously, building the model is a task.
Yes,
it's going to take time and a lot of preparation. Once that's done, is it fast?
It depends on the model. So generally, models that require more calculations can be a bit slower. But unless you're talking about like a neural net, it's probably not going to be like a huge difference in terms of performance, which is probably a good segue to start talking about LLMs.
Yeah. Where we're headed.
I always come back.
Yeah.
So I think I probably talked about on this show before, I'm an AI skeptic. I want to put this up front. So I'm not going to be trying to sell you on LLMs being the best solution for this. They're just the latest solution, and they're a possible approach, but they're not necessarily going to be the best approach.
Okay.
So generally, I'm not going to get into what LLMs are. We've covered that on previous episodes, and I'm sure everyone's sick of it.
Yeah, we kind of built up to them in our descriptions of, NLP to LLM, if you will.
Yeah.
They've had an interesting couple of years here as far as like changes and what's happening with them and places that people are trying to put them.
Yes.
But this is an interesting one. I don't hear about it as much being used for sentiment analysis. So I'm kind of intrigued about like, okay, how do you turn it in that direction, as opposed to like chatting with it. So,
yeah. So probably just give a little bit of context about like the different implementations of LLMs.
Yeah.
So we've talked about LLMs, as I've already said, but basically the LLMs that we're looking at the moment, like a lot of the chatbot ones, are what are called decoder models. So they're just sort of based on a particular part of LLM architecture, and they're designed to predict next word.
Right.
So you create these models, and then you do a process called instruction tuning. And instruction tuning is where you take an LLM that all it does is just spits words out until it comes to a stop token, and then it stops.
Okay.
You train it to expect questions and to output answers. So all you do, take a model that's already been trained, and you input questions and you make it predict these gold standard answers.
Okay.
So you try and get it to output a sequence that's as close as possible. And so these chatbots that you're, talking to, like ChatGPT or whatever, these are instruction tune models. But you don't have to instruction tune models. You can do whatever you want. And something else you could do is you can do this tuning. It's called fine tuning, so that it can predict emotions. So you do, like I said, for the machine learning model, you create a data set which has some sort of text and some sort of emotion attached to it. And then what you do is you feed the text in and you say to the model, you need to be able to predict this emotion. Now, to kind of go back a step as well, I should explain these don't have to be decoder models. They're actually more often what's called encoder models, which are trained to do different tasks. They're not necessarily trained to spit out next word.
They're designed to analyze by encoding the information, pulling the information in and looking at it?
They're designed, it depends on the model. So a long, long time ago, we talked about BERT, which was actually the first ever encoder model. And basically what it was designed to do was do two things. It was presented with two sentences, and it was asked to first predict a missing word in the sentences. And it was also asked to predict what's called entailment. So which sentence precedes the other? Are they in the correct order?
Okay.
So an example could be, I live in France. I speak blank and English. So, the entailment is correct because I live in France should go before the second sentence, and the missing word would be French. So it's just, there's sort of historic reasons that they're trained on these particular types of data. But the general idea is you're just trying to force these models to learn how to deal with natural language. And learning those two tasks really forces the model to basically learn, what is the order of sentences, what's the kind of logical sequence, what words belong in different contexts. So there's nothing special about this task. It's just one way of training these models. Next word prediction is just another way of training these models because it scales super well and it's really easy to create training data compared to this entailment task I talked about. But yeah. So
in our case, we're going to do that with sentiment.
Yes.
In the sense that we're going to kind of let it know what we think the sentiment is, like what. Okay, all right, great.
Yeah. So once we've trained up this encoder model that's really good at understanding language, it doesn't have to be an encoder model, but it usually is. Basically, what we can do is say, okay, I have, say, this book review, and I think that the sentiment of this book review is very negative.
Okay.
So I want you to take in that text and I want you to take everything that you understand about how language functions and see if you can understand why.
Okay.
And then you pass in the next one. I think this is positive. See if you understand why. And you can also do that again with specific emotions. So you can be like, I feel like the description of this book is mostly evoking the emotion of joy. See if you can understand why. And so through being exposed to like maybe a few tens of thousands of examples, hundreds of thousands maybe, the models can then understand, okay, if I see this text, I can understand the specific sentiment associated based on what I understand about how language works. So this is the general idea. And the good news is you don't have to fine tune it yourself because people have nicely done this for you.
Thank you.
Yes.
I wonder if this is somewhat like, it's different than RAG, which I've talked about in the show, where you're taking an existing model and you're augmenting it with a domain space. Like I had somebody talk about, they were working with a company that had this set of almanacs that were all about, weather and when you should plant what food where and all this sort of stuff. And it's very, very domain specific information that they wanted to be able to have in here, and then have the LLM, if it can find that information within that data set, it could provide it. But also you could say, if the question is not within this domain, you could say, don't try to, hallucinate something out of it, which I thought was interesting.
Yeah.
And so I wonder about, is it a similar process? Like, would you say, or is it there's like a unique kind of tuning that you're doing here? It sounds a little more piecemeal as opposed to like vectorizing a database of stuff.
Yeah. So it's more different purposes. Okay. So I'm going to get a little technical here, but not too technical. Okay.
That's okay.
So basically, LLMs contain what's been come to be called parametric knowledge. I think we've talked about it on a previous show. And I think we talked about it in the hallucination episode. So basically, parametric knowledge is just information it's seen enough time during training, and the model is big enough to be able to represent that. So it means that if it comes across something that looks similar to it, it can just, vomit up this sequence that it's memorized, or something close to it. So the problem is, of course, is that models they don't learn everything, because some things will be rarer, but they also will not be exposed to certain things, like maybe 17th century farmers' almanacs as part of their training. So this is sort of the limitation you have. Now, we're also kind of talking about two different tasks. We're talking about... So text classification, which is what we're talking about with sentiment analysis in this context, is like we don't want to be able to generate anything, like from the whole kind of world of things that the model could tell us. We just want to predict these 5 labels or these 6 labels or whatever.
Right. We're almost doing analysis versus more of a generative type of thing.
Yeah, it's more of a closed task, like as opposed to something completely open. And so pretty much like the easiest way to squeeze more performance out of the model is you are introducing new information, doing fine tuning, like in the same way that you are doing RAG.
Okay.
But you're focusing the model so that it can only produce these 5 possible labels. And so it's got less potential error.
Yeah.
Now, the interesting thing is you can actually get these like models that just do generation, text generation. You can get them to do this prediction as well. So you can say to them, hey, here are 5 possible labels, and here's a piece of text. I want you to classify this text. And certain models can actually do this relatively well. This is called zero-shot classification, in that you basically haven't given it any examples. You've just said, here's the task, please do it. Now, RAG, coming back to that, RAG is when you want to be able to generate like some sort of free-form text. But again, you're aware that the model has limitations and you want to be like, please don't use your parametric knowledge because I know we can't rely on it. Here's some additional knowledge that's relevant.
Yeah.
Use that. But I should also say RAG is not a silver bullet. It can actually make hallucinations worse.
I can imagine.
So
okay.
Yeah, it's
All right.
Yeah, it seemed very promising. And then people realize that it's information retrieval and that's really hard. And so yeah. But yes, this is sort of the full landscape to answer your question. It's classification tasks. It's often better to just fine tune the model because you can get more performance out of it that way.
Okay. So like how new is this? Is this like just with the advent of LLMs, people are like, oh, maybe we could try this with this, try using sentiment analysis with it, or has it been a while?
And this is an old technique. I think it first came out with neural nets. Don't quote me on that. But the general technique is called transfer learning.
Okay.
So the idea is that you train a model on a general purpose data set. It could be images, it could be text, it could be whatever. And what you then want to do is make it useful for your use case. So what you do is you say, ignore your previous training goal. Like you've learned all this stuff, you've got it contained in the model.
Right.
But what I want you to do is now focus on a new learning goal, our training goal, and just train a little bit further. Still remember most of what you know,
right,
but just apply that to a new task. So it's certainly not unique to LLMs. It's not new to LLMs, but because we have these, let's say, models that people cannot train at home anymore, it's much more common with LLMs because no one's training foundational models. You're going to go and get an open source model and you're going to fine tune it. So,
and that works in this case. Like if you wanted to experiment with these techniques of like, okay, we've talked about some of the different packages that people can kind of mess with already in our first couple steps along this path. How could they try it out here? Like what would you suggest?
Yeah. So the caveat I will say is that model fine tuning is a bit tricky. It's a bit tricky and technical. So I would say if you want to get hands-on into this and you don't want to like get down a messy rabbit hole, like if you do, go for it. But if you don't,
right,
you basically kind of talk about Hugging Face again. Are you surprised?
Hey!
Wow.
They haven't come up till now.
Oh my God, I know this is a record for me. So basically you can go to Hugging Face Hub and you'll see kind of, if you go to the models tab on the left-hand side, you'll see a bunch of subcategories. So if you go to the text classification subcategory, and then you go and you start typing into the search box, something like sentiment or emotion, you will see a bunch of models that other people have fine-tuned for you.
Nice.
And then what you'll be presented with is the model card. This is give you the information about the model. If it's a well-documented model, and there's quite a lot of them, you can basically usually copy a chunk of starter text like start a code.
Yeah.
And you can just run that and that'll get you started. And
cool.
It's super easy to apply it. And I'm actually putting together a sentiment analysis project at the moment, just checking out my chart.
Yeah.
And like literally me just messing around for, I don't know, half an hour on Hugging Face Hub. I found 2 different models, both doing emotion classification, not even sentiment classification. And they both worked relatively nicely out of the box. So
nice.
Yeah.
Do you find this area promising? Like, do you think this is a good direction for doing sentiment analysis?
Yeah, like
and classification?
The advantages of LLMs for sentiment analysis is the same. The advantages and disadvantages is the same that LLMs have for everything.
Yeah.
So the advantages is these are the models that we have so far that have best understood text in context. Like they really understand, say, the fine relationships between different words. They have limitations. They don't understand everything. And I should say, I don't mean understand. They don't understand, but
right.
You know, they can process and represent these relationships. So that it means if you've got text that maybe is a bit more subtle, it's not people just swearing or because they're angry or putting sad emojis everywhere. Like it could be,
right.
You want to analyze some literature or something that's going to be a bit more fine. Maybe you need to use an LLM. But what I would suggest is if you want to implement sentiment analysis within your organization for a production project, the disadvantage of LLMs is that they're difficult to deploy. They are quite complex because they're very large models. And they usually need GPU acceleration in order to be performant, unless you want to do like a batch run, which is also fine. But for real-time, difficult. So I would just suggest try out all the techniques that I talked about, compare them, and see if the LLM is really giving you better performance. And if it's not, then probably don't need it.
I feel like you have a note on here that they can be expensive. And I feel that that's something that we haven't felt quite yet. But I just see it coming because all these companies are not very profitable based on it, and it's
not
like
very profitable.
Yeah, it's kind of scary the amount of losses that are being written off, and how are we going to eventually make this work? And so that part's a little spooky as far as like, okay, well, here's something that you could maybe think is this will be fixed as a certain cost, but with an LLM it may not be, and you don't even know how long that will be. It's a cautionary tale. I'm just saying.
and I think it's a good one to have. And I would say, like, we could talk about the social and economic and all these implications until people have tuned out in like 2 hours time. But
sure.
If we're talking to an audience of developers who maybe do want to use this stuff, I would say that the general thing to remember is with any machine learning model, the trade-off that you sort of have is, I guess, I know, I'm going to reformulate that. I would say if we're talking about using LLMs, the reason that models like, say, GPT-4 or Claude Sonnet or whatever, you can do everything with them is because they're absolutely enormous and they just have enough parameters to store information about almost any task you could throw at it.
Right.
So they're just doing pattern matching. It's nothing special. So if you really do want to use these models in production for some very specific use case, like sentiment analysis or something like that, like I said, you're going to get more out of the model if you can fine tune it, tailor it to your specific task. Don't try and take shortcuts. And then that means you can probably use a smaller model, probably use something that can even run locally. And these 2 models that I'm playing with right now.
That's what I was wondering about. Yeah.
Yeah. They're running happily on my computer. I am using an M3 with a GPU acceleration, but they're not making, my computer cry. So just
again, you're probably doing batches of stuff and not have something like actively running.
Yes. And I'm not needing to do real time, but like, honestly, even if we're talking about like, I don't know, like say a simple binary classification task, like positive or negative, you're probably going to find like relatively small models can handle this. Like if you're not talking about emotion classification, which is a bit more subtle and fine.
Right.
Yeah. So you don't
Okay.
need the big boy models. You don't need the like $40 per hour EC2 instances. You can get away with something smaller and just try that first.
Do you know of examples of this being used by organizations currently? Like you mentioned some different projects people can check out on Hugging Face and so forth, but can you think of implementations that are being used right now?
So not for sentiment analysis again, but I do know, so previous workplace that I worked in, a friend of mine works on a salary prediction model.
Okay.
And basically they're using encoder models to create like document embeddings, like vector representations of parts of job text and CVs and things like that in order to be able to like, capture the information about these particular pieces of text and pass them in through models. And it's being used like super successfully. Like that workplace, we started working with LLMs in 2019 or something. So they've been basically using that. And actually, funny story about that workplace. A friend of mine messaged me from there like 6 months ago and he's like, "You're not going to believe this." So basically, the CEO came to our head of department and said, "I'm very concerned. What is your department doing with AI?" And she's like, "We've been working with AI for like 5 years. What are you talking about?"
Yeah, if you want to categorize it as that.
Yeah. Like it's the exact same models though. So like,
right.
Yeah, I laughed really hard at that.
Like they were interested in that they could define it somewhere and say that we are using it.
Yes, exactly. And so it was also like, I don't know. Sometimes I think it's just they were probably getting pressure from the stakeholders who wanted to know that.
Right.
Yeah. No,
I mean, it is this buzzword that it seems like if you have a company, you need to have it listed. I mean, I just spoke to this guy about his project called Pie Sheets, and he's like, I have to have it there, and I'm like, I get it, I understand.
Wait, was that Chris?
Point, so. Yeah, Chris Laffer.
I just met him at Pi Data Amsterdam. I went to a meetup there 2 weeks ago. The show? Yeah. That's hilarious.
Yeah. We were talking about it, but he was talking about like he's like, I'm trying to, get investors, and it's like I need to do that, and I get it, I understand it, So it's just funny, And in that case, it makes sense, he's going to use it to help with helping you with the coding inside there, and especially for somebody who's moving from potentially something like Excel to something like this tool. It's like, okay, well, can you give me some help in the programming department? What's the Python code that's needed here? So well, it sounds like we get people a handful of places to start. We'll obviously include some links to that. I have the couple articles on Real Python about this that kind of maybe take you a little bit further back into some of these tools that have been around for a while. And then sounds like you have a couple links that we could get for that stuff on Hugging Face.
Yeah. And when my blog posts are out on PyCharm, I can also send those over and we can add those.
Yeah.
But yeah, maybe my takeaway would be just because some techniques are older doesn't mean that they're worse.
Right.
And yeah.
It's a great place to learn what's happening too, and kind of learn what is it you're looking for?
Yeah.
Especially if you have stakeholders, like you can kind of give them examples of like, well, this is what we're trying to do. Here's another question though. I know Hugging Face has a lot of these models in this sort of situation, but you might have a unique circumstance and you're looking for a data set. Maybe you don't have your own places you could find a data set to study sentiment analysis, or places you would say, go search here.
Yeah. So I think my favorite place for getting these sort of data sets is Kaggle data sets.
Okay. So Kaggle's still the good place.
Yeah, still a good place. So you just need to create an account. It's free, and then you can download them.
Okay.
I am working at the moment with an absolutely beautiful data set that someone mined on books.
Okay.
For this little sentiment analysis project.
Like reviews and stuff too, or?
Descriptions, actually.
Descriptions
so
of the books. Oh, okay.
But yeah, like I'm basically just trying to build like a book recommender. So yeah, but it's people are very generous with their time in putting these data sets together. Please do make sure that you reference them properly if you use them. because it takes work.
There was this tool that I used to have for music that I loved. I can't even think of the name of it anymore, but it was this is pre Spotify and Apple Music and all this sort of stuff. But it was like you could take your iTunes library and you could say it analyzed sort of emotional aspects about certain stuff like tempo, like angry or sad or, whatever kind of different sort of things. And so you could kind of dial up this sort of mood playlist and it would find all these other songs that were in that quote unquote mood. And it was really good. And I'm like, gosh, I wish there was something where I could rebuild this tool because it's something that's so missing. And Apple Music's gotten better, but generally it's just clueless on certain stuff. And it would always play like, it's like, okay, I love Crowded House, but that song doesn't have to be in every playlist. Kind of thing. It's like, can you just go deeper into my library and unearth some gems? So I like that idea of the recommendation system. I feel like some of these tools have kind of gotten a little, I don't know, confused. I feel like the recommendations have not been as good lately, but I don't know if that's just a personal observation. So
I don't know. Spotify has been killing it for me lately, so I'm not going to speak a bad word about them. They make these day lists and they're off the chain. They're so good.
They're doing great. Okay, good. All right. Maybe I got to play with it again. I've taken a break. Maybe. So cool. Any conferences or things coming up you want to mention? Or you got a nice little break here for the holidays?
I almost got away with it. So I've got 2 short ones, just very small conferences. So I've got one called ZSBit in Poland. So just a drive over the border from Berlin.
All right.
So that's just a general conference. It's some guys that I actually know from PyCon US, and they're part of the org for EuroSciPy at the moment.
Okay.
So we've been trying to line this up all year, and they've had 2 other of these small conferences, so I finally can come. And then I'm going to an AI community day in the Netherlands in early December.
Okay.
And then that's it.
Yeah. This might come out around that time. I'm thinking December.
Okay.
Well,
awesome.
Thanks for coming on the show again. It's always fun to talk to you, Jodie.
It's always a pleasure. Thanks for letting me geek out about sentiment analysis.
Oh, no, it's always fun, especially when you provide all these resources for people to play with. So,
yes, go and play.
All right. Thanks.
All right. Bye.
And don't forget, our sponsor, Sentry. At Sentry, we don't just build tools. We use them to debug our trickiest slowdowns. Read more challenging debugging stories at blog.sentry.io. I want to thank Jodie Burchell for coming back on the show this week. And I want to thank you for listening to the Real Python Podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python Podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and I look forward to talking to you soon.